Hello everyone, this is a short video about Fischer projections. So Fischer projections are basically used to represent sugars. Why sugars? Sugars have multiple chiral centers and they're normally drawn in a vertical fashion like this. Like I have copied and pasted some examples from the book. Notice these are, this is how we represent sugars. But then they have multiple chiral centers, and the way we kind of assign now we don't need to be able to name these sugars, at least not as of now. So now if I were to think about this structure, there is 1, 2, 3 carbons. And then if you think of the first carbon, then that is not chiral because we have 2 oxygens. Basically, we'll consider this as 2 oxygens. So that is not chiral. This last carbon is not chiral, but the one in the center is chiral. So we need to be able to assign the priorities for the chiral carbons and then call them R's and S's. Not only that, we should be able to draw the structures like we have been doing for regular line diagrams. Like for example, if I were to have something like this, we have seen these examples before. So 1, 2, 3, 4, we assign the priorities, and then we make sure the fourth priority or the least priority is on the dash or going behind the plane of the paper. And then if we'll see how that's are arranged. So these are going in the clockwise direction. So we'll call this R. This is 2R, 2-butanol. We know this by now, right? So now if I were to use the same logic here to assign the R's and S's, it gets a little tricky because we don't have dashes and wedges anymore. Everything is drawn as lines. So one thing you do want to understand here is these intersections. Whenever you draw these structures, these intersections, these are carbons. Those are carbons. And if you notice, there is multiple OH and H groups, right? So to make it easier on ourselves, I'll redraw the first structure. I have redrawn the first structure already. So now this is my chiral center. The rest two are not. So now here, if I were to start assigning priorities, this is my first priority, second priority, third priority, fourth priority. However, we do not know which is a dash and which is a wedge, So one tip for you is we can consider horizontal bonds as wedges and vertical bonds as dashes. So that means, one more time, horizontal as wedges and vertical as dashes. Now, if I were to make all of them wedges and dashes, now I don't know which is going behind the plane of the paper and which is going on the same side of the paper. So we can always assign only one wedge and one dash. You may ask, how do I know which one to assign a wedge and which one to assign a dash? And the answer is it does not matter. We can do that exercise and show ourselves that it does not matter. So now I'm going to assign the one on the top, which is the second priority as a dash and the first priority as a wedge. Now, as we have been doing, the fourth priority has to be on a dash. So what am I going to do? I'm going to switch my 4s and 2s. So this is my 4 and this is my 2. So now I will look at which direction these are going. So now this is my 1, 1 here, 2 here, 3 here. So this center is going in this direction, which is the S. After the flip, again, if you remember from the previous classes, we do not need to write this, what happens after and before. I'm just showing this for you one more time. So this is S after the flip. So originally should have been an R. Or originally. So now just to prove it to ourselves, let us say I switch the dashes and wedges and see if we come up with the same configuration. So I'm going to redraw on this for myself. OH, carbon, NH2, hydrogen, and CH2OH. So now let us say I'm going to switch my dashes and wedges, meaning I'm going to make my hydrogen a wedge and then my CH2 a dash, right? The priorities do not change. 1, 2, 3, 4. So what do I do now? I need to put my fourth priority on the dash. So I'm going to put 4 here and I'm going to put 3 here. So now notice if you were to consider 1, 2, 3, so this is still going as a yes. This is still a yes after the flip. Yes after the flip. So or originally. or originally. So bottom line is you can make any of the horizontal bonds a wedge and any of the vertical bonds a dash. Your configuration will not change, or S will not change. My one easy way to do this is probably just set one for yourself, either left or right. One is a wedge and one is the one going on the top is a dash, or set one thing and kind of stick with it. It's okay if you interchange also, but just wanted to show you that it does not matter. So that's how we would do it. If there is only one chiral center, it's really not a big problem. So that is fine. Let's do one more for practice here. See, so the second one here, HOH, COH. So this is my aldehyde group here, and then CH3. So as we said before, we are going to set one as a dash and one as a wedge. One as a dash and one as a wedge. And now assign our priorities. 1, 2, 3, 4. So now I'm going to switch put 4 here and 2 here. So 1, 2, 3. So this is going as a or after the switch, after the flip or switch. So S originally. For the record, one more time. We don't need to do after the switch. I'm just kind of doing this again for you if you need a little refresher. So S originally. So that means this is a yes confirmation. And again, in this Fischer projection, there is only one chiral center. So let us go to something which is more complicated, which is 2 chiral centers, 3 chiral centers, 4 chiral centers, and so on. So that means this is a chiral center, this is a chiral center, right? So let me work on the first structure here. We don't have to redraw, I can do it here. So now if I were to look at my first carbon, 1, 2, 3, 4. So if any of you are wondering how I know what is 2 and what is 3, 1 and 4 should be straightforward. Anybody is wondering, then so notice whenever I have a double bonded carbon, I can consider this as 2, double bonded carbon, double bonded to oxygen. I can consider this as 2 oxygens as far as the priorities go. Now here, if I were to consider this third carbon, I have a hydrogen and an OH and a CH2OH. So carbon, carbon, that does not break the tie. Hydrogen, hydrogen, that does not break the tie. Oxygen does not break the tie because I also have an oxygen. So what breaks the tie? This second oxygen, when compared to the carbon, breaks the tie. So the second oxygen breaks the tie. So that means this is my second priority. The carbonyl group or the aldehyde group is my second priority. So that this one is third and then fourth. So now again, like we did before, I'm going to make this a dash and I'm going to make this, the other way around. I'm going to make a OH a wedge and the CHO a dash. So now I still need to flip. I'm going to put my 4 here, 2 here. So 1, 2, 3. So it is going in the anti-clockwise direction after the flip. So it's S after the flip or original. So now let's do the same thing for this next priority, carbon on the next priority. So just to not make it confusing, I'm going to erase those numbers or priorities. 1, 2, 3, 4. Again, look at the priorities here. 1 and 4 are straightforward. 2, if you look at this carbon, this is CHOH, this is CH2OH. So that means the carbon on the top has one hydrogen, one OH that does not break the tie with the third carbon. But other than one hydrogen, it also is attached to another carbon. So that breaks the tie. So second, the one on the top gets the higher priority versus the one on the bottom. So now again, I'm going to make this a wedge. I'm going to make this a wedge and make this a dash. Again, does not matter. You can put the one on top as a dash also. So I'm going to flip and put my 4 here, 3 here as a flip. So 1, 2, 3. So notice here 1, 2, 3. It is going in the OR direction after the flip. So originally it should have been an S. So OR after the flip originally should have been an S. So now, once you get the hang of it, the more time consuming part is this. If you have to go from the Fischer projection to the regular line diagram. So now we have to do the line diagram. So now I'm going to count carbons here. 1, 2, 3, 4. I have 4 carbons. Again, I'm going to erase some of these numbers. So I have 4 carbons. 1, 2, 3, and 4. So now my first carbon here has a carbonyl and a hydrogen. So that is my aldehyde group. The second one has OH and a H. And the third one has OH and an H. I do not know if I am putting them in the right direction or not as of now. This last one has a C. This is a CH2OH. So now these two are my chiral centers, my second and the third. I need to make sure when I draw this, I need to make sure my R and S, the stereocenters are also correct. So now we already decided that the second carbon is the second. When I say second carbon, I'm going to number this as 1, 2, 3, and 4. So the second carbon here is R. So let me relabel this. This is 2R, 3S. Right, 2R3S. So that means this is my second carbon here, and then this is my third carbon. So my second carbon needs to have an R configuration. So again, I do not know if I'm doing this right or not. So let us say I'm going to make this a dash, a wedge, and then I'm going to make this a dash. So now if I were to put in my priorities, 1, 2, 3, and 4. Notice 1, 2, and 3, and 4. So now if you were to look at this, this is going in this direction, 1, 2, 3. So that's correct. That is an R. Right, that is an R. So can you come up with if you were to ask me if I can come up with one kind of method to do this, it is difficult. So let's try this out again. So now the 3S, I had the third carbon has to be an S. So to make my life easier, let's assume I'm going to do this a dash wedge and this a dash because it's I can do this on my own, but still my R or S confirmation should be correct. So now here, if I assign the priorities 1, 2, 3, 4, so it is going in this direction, which is an S. So 2R, 3S. That is correct. That is correct. So it is not difficult or anything, but then when the number of carbon centers or number of chiral centers in a molecule increase, it gets a little tricky and also time consuming. So let's do one more example here. So this one is 1, 2, 3, 4. I'm going to make this a wedge and I'm going to make this a dash. I'm going to flip my numbers 2 and 4. So 1, 2, this is my 1, 2, 3. It is going in this direction as a yes after the flip. So R originally. R originally. So now here, if I were to do the same thing, if you want, you can start drawing the line diagram also. So that's my first carbon, second carbon. I need it to be an R. So this is my first priority, second priority, and my third is going to be here fourth. 1, 2, 3. That is an R, right? So now my third center, 1, 2, 3, 4. Again, notice like before, this is CHOH, CHOH, that does not break my tie. If I keep going to the next carbon, I have a carbonyl here with 2 oxygens. So that gets my higher priority. This gets the lower carbon gets my lower priority, or the one below the carbon on the bottom gets the lower priority. So 1, 2, 3, 4. One more time. A dash, sorry, a wedge and a dash. So I'm gonna flip my numbers here. So this is my 3, this is my 4. So let me erase these two. Keep looking at one numbers at a time. So 1, 2, 3. So it is going in the R direction after the flip. So originally, yes. 3, yes. 3, yes. So now let's do this. Let's continue here. So now my third carbon, OH and H. So 1, you have to make sure your priorities are correct or your confirmations are correct. 1, 2, 3, 4. So that's an S. Now my last carbon here. First priority, fourth priority, not a question. Second priority, third priority. So now this will be my dash and this will be my wedge again. This will be my wedge again. So let me erase some of these numbers. So 1, 2, 3, 4. So now I have to put my 4 on the dash. So I'm going to put my 4 here, 3 here. So 1, 2, 3, 1, 2, 3. It is going in the S direction after the flip. So before it should have been R, 4R. So now I have to draw my 4R here. This is my fourth carbon and I have a CH2OH here. I have a hydrogen. So 1, 2, 3. So 1, 2, 3, that's a R. Right? So that's how we assign the priorities for Fischer projections and then transform them into line diagrams. The more number of carbons, chiral centers we have, it takes longer and maybe a bit tricky also, but otherwise we are going to use the same priorities, how the rules for assigning priorities and to determine the chiral centers.